Okay, we've got an experiment carried out to investigate the probability of obtaining a tail when a biased coin is thrown, and the relative frequency of a tail was calculated. Now then, relative frequency is probability by carrying out an experiment. Okay, it's not. I mean, we used to probably, like, if I roll a dice, the 6 numbers are all equally likely. Okay, that's not always the case. Sometimes we have to find out the likelihood of something happening through carrying out the experiment. And this is an example here where we got a biased coin, so we don't know what the probability of a head or a tail is, so we do it by carrying out the experiment over a certain number of times. And along the way, after each block of 20 throws in this particular case, I calculate what that relative frequency is, or what the probability is. So as we can see here from the graph, after 20 throws, the probability is whatever the value of this dot here is. So I need to the scale. Okay, so that's 0.5 there. So it's halfway between 0.5 and 0.6. So that'll be 0.55. Okay, and so on. After 60 throws, the probability was 0.6. Okay, so that's what's happening. Now, then, which reading do you think gives the best estimate for probability of obtaining a tail? Well, the more times you toss this coin, the more reliable your answer is going to be. So the best reading is the last reading, where I actually carried out 100 times. Okay, so the best estimate is after 100 throws. Okay, and the reason is because this is the probability for the most number of times the coin was tossed. Okay, so the more times you carry out an experiment, the more reliable your answer. So it's always the final value that's the best value. Now, part B says how many tails were obtained in the first 60 throws. Okay, now the relative frequency is that of the number of tails. So after 60 throws, the probability of it being a tail was 0.6. So for 60 throws, probability of a tail is 0.6. So to find the number of tails, I'll work out 0.6 times 60. Okay, so the number of tails will be 0.6 times 60. So the digits 6 sixes are 36, and that naught moves the point over, so there's no adjustment made there. There will be actually 36 tails. Now then, how many heads are obtained in 100 throws? Well, 100 throws, this probability here is exactly between 0.6 and 0.8. So after 100 throws, the probability of a tail is 0.7. Now I want to know how many heads. So if the probability of a tail is 0.7, the probability of a head is 0.3. They go add up to 1. So the number of heads will be 0.3 times 100. And that's move the point 2 places over, 1, 2, and that will give me 30.